Hello, everyone. Welcome back to the AAS YouTube channel. And we are going to launch a new series. This one's going to be the AAS Journal Data Editor Series. And I'm super happy to have one of the AAS data editors with us, Greg Schwarz.
Hey, Hi, Frank. How are you?
I'm doing well today. How are you?
Not too shabby, considering it's week 9 of the quarantine here. Holding it together.
Good. Where are you at?
I'm in the outer suburbs of Philadelphia, Pennsylvania.
Okay, very cool. Is that your baby picture in the background?
It is not my baby picture in the background. It's one of, this is a sort of a shared office with my wife. That's one of her pictures in the background there.
Oh, very cool. Very cool. Yeah, it's always kind of fun when you get on here and these see what people put on their backgrounds. Fortunately, you don't have one of those Zoom backgrounds where you're.
Oh, I've got them. I'm just restraining from using
them. Well, feel free to turn it on. Feel free to turn it on. It's okay.
Maybe one of the later series, though.
Okay. Yeah, speaking of, I'm glad you brought that up. So we're planning about 6 in this AAS Data Editor series. And so we're going to lead this one off, this inaugural one, with what are the services provided by the AAS journals and the data editors and data. So, Greg, why don't you take it from here and talk about some of the services provided, or what do you do for the AAS journals as a data editor, and just let people know.
Sure. The data editor position has been around for 20 years now. That's how long I've been here with the AAS. We have another data editor who started about 5 years ago, Dr. Gus Minch, who I think will be on some of the later series.
So you started with Rob Kennicott.
Correct. And my understanding of the position was they were transitioning from Helmet Apt, who was the editor at that time, to Rob Kennicott, as you pointed out. And I believe, I don't really remember if it was Rob that wanted this position or some forward-thinking people on the pub board during this transition that wanted it. But their idea at the time was, CDS in Strasbourg, France are doing some fantastic work with their Sinbad and Vizier series. Mm-hmm. Maybe we should be a little bit more in tune with what they do. So the idea was to bring in a PhD astronomer to work on kind of formalizing very large data tables in a format that was not just the printed page. I distinctly remember when I started, there was a paper published that had, I think, 900 pages of tables. It was some giant white dwarf thing. It was just, crazy. You feel really bad for any undergrad that had to kind of transcribe that thing. So the idea was that there was already, you could see that there was this need for it. And we had already been in the electronic publishing for, about 5 years at that point, if you start with the letters.
Right.
And there was already infrastructure in the sense that the French were sort of doing a lot of this stuff with their catalogs. So everything sort of all came together. And since that time, we've kind of moved beyond just tabular data. If you want to show that one graphic I supplied with you, I can walk you through all the things that us data editors touch.
Sure. Let me ask you one question on your background. So you mentioned a PhD astronomer. So what do you like to do for research?
My research is all on cataclysmic variables, specifically classical novae. Back in the day, I did a lot of work with the IUE satellite, ultraviolet observations combined with ground-based optical and infrared data to early I was doing modeling of the initial optically thick phases, but then later more of the line emission analysis to try to get tease out abundances and things like that to really determine what the masses were and what how much these things were kind of polluting, if you will, the ISM, stuff like that.
Yeah, very cool. Very cool. Okay, let's pull up the slide. And we will do some of the data products offered in the AAS Journal articles.
Right. So as I said, so what this table shows, or this slide shows, is something that I've shown at a couple other conferences. And I basically listed in the bullets are the sort of data products that we offer. And in the parentheses are 2 numbers. The first number is the year we started offering this data service. And the second number is roughly the number of items that we've published. So for example, I already talked about tabular data. We put these into what we call our machine readable format, which is basically a slimmed down version of what CDS does for their Vizier catalogs. That, of course, as I stated before, started in the year 2000, and we've done over 13,000 of these things since then.
Is there anything authors need to do to get something in a MRT, or is that something you do?
The answer to that is both. We do have ways for authors to do this. We actually have a online service, a tool, if you will, that people can go to. I don't have the URL.
We will put that URL in the description below the video.
Yeah, I love it when you can point down and that it just magically appears.
The description down below.
But yeah, so you can, try to create your own. I would say only a small fraction, a few percent of authors try to do that themselves. Okay. Most of them just give us whatever. That can range from CSV files, IPAC type formatted things, even LaTeX tables. And my colleague Gus and I have many different techniques to unpack those and reformat them into this machine readable standard. These usually consist of a metadata standard that follows the CDS formats, and then the actual data that's formatted below that. So in theory, that gives you everything you need to read it in and do whatever you want to it. There's actually AstroPy tools to do this. There's IDL packages that can do this. For the most part, it should be very trivial for anybody to manipulate these things.
And people would get these by going to the online article and then clicking on
data
or whatever it may be. Yeah, the data link that's there. Okay.
Exactly. So you can clearly see from the numbers, that's the number one thing. Astronomers love tables. We like to distill large images down to bigger tables. We've also offered animations for a long, long time, since even before I started. But what changed in 2016 is we developed the ability to stream them inline in the article itself. So as you're reading along in the HTML article, if you see something that has an animation, it's got the little play symbol, just like you would be on YouTube. You click on it and you can go from there. So long gone are the days where you just had a tar package and you downloaded the thing and you didn't know if it was an MPEG or an AVI or an animated GIF or something like that. So now everything is streamlined, and it takes all the guesswork out of it for the reader.
For the formatting, yeah.
Right. It's kind of like in the old days when, if you were on a Windows machine and, you didn't have the right
codec.
Yeah, a lot of things like that. You could never be sure if things would work.
I remember the days when people would stick a camera in front of their monitor and then shoot it on tape.
Right.
I just like, oh man.
Yeah. I think you're kind of almost referring to our video series. Just take a step back down memory lane. I think you touched on this in a previous series, but we used to have VHS animations that were shipped to people on VHS tapes or PAL tapes if you were in the UK back in the early 90s. So it was way ahead of its time, and unfortunately we moved on to bigger and better things.
We're modern era these days.
Yeah, I should say that for animations, this is very standard in the helio field. The solar physicists love their animations. It's slowly becoming more and more common outside, especially in big simulation kind of data, right?
Right.
The next thing was figure sets. That's basically, you think about tables, it makes sense. You don't want to print 900 pages of tables. Well, likewise, you don't want to print 900 pages of figures. So we actually I think this started in like 2015 when authors came to us in 2004 and said, I've got 1,500 pages of figures I want to print, but I don't want to pay for it. What can you do for me? So we created a figure sets. And what that is essentially like a virtual flip book that allows you to kind of rapidly scroll through this list and find the exact one that you want, or click a download button and get the whole set. So that's just a way to kind of handle the equivalent of figures as we do for tables. And it's fairly popular as well. Going back to the other question that I think underlines a lot of these things is how much work does an author have to do? Again, for that one, really not much at all. If you want, we'll set up the markup, but it's all documented in our online guides. that you can read if you want to try to figure it out yourself.
I just want to emphasize a point you said there. You know, by using figure sets, you can save yourself on some of the quantum charges or page charges, as they're more commonly known.
Publication charges.
Publication charges. So yeah, you can save yourself some money by using figure sets. You got a lot of them.
That's definitely true, and that's something we try to recommend to people is to think, because we found that a lot of people aren't necessarily aware of these services that we offer, and once they are, they can start to become a little bit more savvy, if you will, on them. So data behind the figure is essentially, you know, we couldn't come up with a better name. I mean, it's exactly what it is. Sometimes you have, you know, it's just like, I see that light curve. I really want that data there, and it wasn't provided in a table, so we can ask for it. That basically takes two flavors, something that's like a vector drawn, you know, point, that could easily be put in a machine readable format. Or if it's like an ALMA image or something like that, then we're obviously talking something more like FITS. We'll take either flavor or even something in between, like HD5 if necessary. And again, as long as you provide the data, we'll work the magic to put it in the correct format if necessary.
Right, and this helps gets away from the days when people would take a figure and they would digitize it themselves, or they would just take a ruler and, you know, try and rule across and get the data points off the
right. So. Yeah, I think the Dexter days is what the tool was called, right? So as you can see, though, from the numbers, it's still not super exploited. But I think, you know, as people become more and more aware of it, it's really something that people should try to take advantage of. My advice is try to put yourself in the reader's shoes and say, if I was reading my own paper, which of these figures would I really want to get my hands on the data behind? And from my own point of view, coming from a time domain background, I really try to hammer on people that are doing transient type events, things that, you know, you can't go back and look at them anymore because they're done. So that's the kind of stuff that really piques my interest, and I try to get people also involved. I've had people come up to me in meetings and say, you know, especially like some people in the supernova group, it's like, well, you know, we're creating these vast archives to store all these spectra and light curves of all these things so that we can, you know, collate them all together, but people sometimes don't provide the data. So that's something that we're trying to really capture, because once it's gone, right?
Yeah, and I'm, for people who don't know, when a manuscript comes in, the AAS data editors will typically go through an article and make suggestions for the scientific editor to pass on to the authors, and certainly one of those that are prevalent in the time domain is they will say, gee, wouldn't it be great if there was data behind the figure in figure X? And so you will often see, at least for me, quite a few of those going out.
Right. I think we'll talk about in details how that works in a different series, but in essence, you're exactly right. We're just trying to, you know, raise awareness of these features and trying to get people to be a little bit more proactive in supplying this. That's not to say that, you know, if you've got HST spectra, you know, unless you've done something very special to it, anybody can go to the archive and download it. So we don't necessarily need it in that case.
Right.
So interactive figures, now we're getting into more recent time. That is kind of an exciting thing that we've been working on. That is things like three-dimensional figures where with your mouse you can rotate around and you know, circle around it or zoom in. We also just started I don't know if you've done a series on this, but we partnered with the AstroPi group to work with their time domain series to create the ability to, as part of your process of just creating figures, to make it easy to make an interactive figure. And if anybody here, shameless plug time, if anybody is going to be at the summer meeting here, the virtual summer meeting, I'll be presenting a virtual poster showing my own experience working as a complete Python noob, trying to get this to work. And, you know, we can show how this works. And the whole idea is try to make these things part of the day-to-day process for most astronomers, so that making an interactive figure is just as easy as making any other kind of figure. That's the problem with the interactive figures here, is they take a lot of effort. Unlike everything else where I said before, where Gus and I can really help you put these things together. Interactive figures takes a lot of work on the author's part. And so partnering with AstroPi to sort of make it part of the process, we hope will go a long way into making this a more widely accepted feature, especially exoplanet people that work with TESS and Kepler data. It's perfectly suited for things like that.
Yeah, and I will just mention as a teaser, in about a week or so, we will have a video coming up with Mariana Kunkel. And we highlight a number of the interactive figures that were in her article. This is mainly Gaia data on streaming, and I found them absolutely fantastic because you can rotate to a particular position, you can turn stuff off and on. It's just a lot more capability to it than what you could do in a static figure. So
right, it really allows a author to tell a specific story and to get in on specific things that they want to show. But at the same time, interactive figures are essentially data behind the figures because you can download the data behind it. So for example, if I just have a giant field and the author's trying to tell some story about that, but I'm interested in some other subset, you know, essentially the trash part there, I can still get the data and do whatever I want with it. So it's really a great way to hit the best of both worlds, I think. But as you can see from the numbers, it's still rather low. And the question is, I think in my mind, is that because people don't know about it yet, or because the barrier to do it is still pretty high? So we're going to be pushing it pretty hard, and we'll see if these numbers change too.
Yeah, I would say both. It's awareness and then barrier to entry.
Right. So just to wrap this up then, the external repository support is something that Gus really has been pushing when he started 5 years ago. And that is that, as you can see, we cover a lot of data things, but there are still other things that we can't. For example, like if you have a database or you've got just massive gigabytes of data, that's something that we really can't handle. So for sort of everything else, we have external repository support. We try to push people to go to places like Figshare or Zenodo or Dataverse or Canfar or stuff like that and put their data there. This is also great for people that are doing code.
Right.
They create their own codes in GitHub or whatever. We ask them to, you know, put a static version in Zenodo. That's a nice way to transfer over to do that. And then you've got a nice citable link.
A DOI.
Yeah, exactly. So those are sort of the things that we offer. Actually, it's all the things we offer. And I'll just kind of wrap up this slide here by saying, again, there's 2 of us that do this, and we, you know, basically create about 2,000 of these data products over the course of the year. Most are machine readable tables, as you can see. And this represents about 20% of our published output. So I think the takeaway from that is Gus and I are very busy most of the
time. Yes, you are. I will say that. You guys are quite active on the manuscripts that I handle and stuff. So that's really cool. Greg, I want to thank you so much today.
Well, thanks for having me.
Bring with us some of the things that the AAS Journals offers in data, and in particular what you and Gus do on the data editing side. So
happy to share.
Thank you. So thank you, everyone, and we will see you on the next one in this AAS Data Editor series. Bye-bye.